All right, question number 3. Let's finish this. So the mass of yeast in a culture measured in milligrams at t hours is modeled by the function y of t, defined here, where f is a continuous function such that f of 12 is equal to 20. Okay, so f of 12 is equal to 20. Okay, cool. Not necessarily y of 12, but y of 12 will be equal to f of 12, which will be equal to 20. True. All right, cool. For the first part, find the limit as t approaches infinity of y of t and explain the meaning of the limit as t approaches infinity of y of t in the context of the problem. Okay, so the limit as t approaches infinity of y of t is going to be equal to the limit as t approaches infinity of this expression right here, since this is the part that will approach infinity. So then that's going to be 600 over 20 plus 10 e to the negative 0.05 t minus 12. Okay. Let's see if I can get this right. So at infinity, so that would be like right here. So if it's a negative power and you're valuing it at infinity, is going to approach essentially 0. Eventually it will just get to 0. So I think all of this right here will just become 0 because it'll be 10 times by 0. So then you'll just be left with 600 over 20. And so then if it's equal to 600 over 20, that's going to be equal to 30, I think, if I'm doing that right. So then as far as the meaning of y of t in the context of the problem, I would say as, what does t represent? As t in hours approaches infinity. That just sounds weird. I don't want to say that because, yeah. I'll say as t in hours increases, I think it'd be safe to say that. Again, I just think it's weird to say approaches infinity because, yeah. So as time in hours approaches infinity, the culture in milligrams, no, I'm going to just take what they have here. I'll say the mass of yeast in a culture. I'm really just going to copy what they have. Yeah. So the mass of yeast in a culture will approach 30 milligrams. Yep, will approach 30 milligrams. So I think that's the best way to do that. So we have this part right here explaining how to show it mathematically, and this means this is what it actually means in the context of the problem. All right, so for 25, is the function y continuous at t equals 12? Let's see. So f is continuous function such that this right here, so f is continuous, so this is a continuous function, but we need to show that y is continuous at 12. So we've kind of already done this before, but if we're going to justify continuity, we have to show that the limit as t approaches 12 of y of t is equal to y of 12. That's what we need to prove. So what is the limit as t approaches 12 of y of t? So we would have to evaluate it from both sides. So from the left side. So that's going to be equal to, so we need to plug in 12 for this function. So we're going to plug in 12. So then we're going to get f of 12. And f of 12 is given to us as 20. So this is going to be equal to 20. Now we need to show the limit as t approaches 12 from the right side of y of t is going to be equal to, we're going to plug 12 in here. So we're going to plug in 12 there. So that's going to be equal to 600 over 20 plus 10 e to the negative 0.050, because if I plug in 12 here, that becomes 0. And then that's going to be equal to 600 over 20 plus 10, because this will become 0 right here, all of that, and e to the 0 is 1, and 1 times 10, 10. So this will be equal to 600 over 30, which will be equal to 20. Perfect. And since, I should also say right here, this is equal to, I guess I'll just say this, y of 12 is also equal to 20, because we just showed it right. How about I say this, f of y of 12, so plugging in 12 here means I'm going to plug in 12 here. So f of 12, which is going to be equal to 20, which is how we evaluated the limit up here. But all right, so yes, y is continuous at t equals 12, and I think our justification is good right here. All right, let the function y is continuous at t equals 10. So right here, it doesn't really say how, but it just says that it is, which is good, which is fine by me. So we don't really need to check it by plugging it in, because we wouldn't know what f of 10 is. That's not given to us. I guess yeah, it's not given to us, but we could plug in 10 here and find it out. But in any case, we're continuous at 10. Okay. Is there a time t in the interval from 0 to 12, so from 0 to 12, at which y of t is equal to 18? So it sounds like they're wanting us to use the intermediate value theorem. So on this interval, let's find the y value. So we need to find y of 0, we need to find y of 12. So y of 0 is going to be equal to, we're going to plug in 0 here. So that's going to be 10 e to the 0 power, which is going to be equal to 10. Now we need to find y of 12. So y of 12, we already found up here. Y of 12 is equal to 20. And so the y value here is 10, the y value here is 12, and 18 is between. So 10 is, I'll just say this, y of 0 is less than 18, and that's less than y of 12. I'm going to say that right there. And then I'm going to answer by saying, by the intermediate value theorem, there must exist a time for 0 to 12 such that y of t is equal to 18, because y is continuous. Always state the condition, and f of 0 is less than 18 is less than y of 12. That's what I'm going to put for my answer. All right, and that is it for question 3.